Welcome back, everyone. So, we will continue with grounded theory, where we stopped in the previous video. Robin Hood's forest limits interactivity and hence encourages a long term investment strategy. Because they are designed to be minimally interactive, existing game taxonomies and design principles are less applicable to this genre. So there is, if you don't know what this taxonomy, it's about the standard process in the industry that allow us to measure the usability and success, or basically the quality of a certain strategy. So, for example, existing literature on game taxonomies, prior terms and definitions related to idle games were incorporated into the analysis. Based on this analysis, Sultan Al-Harthi, 2018, produced a taxonomy with two basic ways to characterize the games. One based on key features and one based on interactivity. So the first is features. The data or the main point was categorized via feature, and then the other was categorized via interactivity. From the former, they define incremental games as idle games in which player selects resources to generate, waits for them to accumulate, and spends the resources to automate resource generation. Figure 9.11 illustrates the open codes, resulting concepts, and categories developed for incremental games. This shows that four categories of incremental games emerge from this analysis: micromanagement, derivative, single resource, and multiplayer. So here, game name or game feature, adventure capitalist. Play description: you start clicking a lemonade stand and collect money, spend money to make upgrades, increase production per click, start hiring workers and increase production per second. When you have enough money, you can buy new businesses, automate it, all your businesses to increment more money and leave the game progress. Game mechanics: click to gain money, automate production, make upgrades to damage per second. Rewards: one currency, which is money, is reward in return. Interface: graphical. Interactivity level 7, progress rate 9. As you can see, these are the features of the game. And you're trying to observe the measure of that in scale of 1 to 10. Or depends, you can measure it quantitatively or qualitatively. Overview: this is a single player game which requires long cycles of clicking at the start and making a number of upgrades. Production rates reaches $390 per second in less than 10 minutes, and you gain 1 million in cash, making the game progress faster. Here are the open codes. So these are the concepts and categories that emerge. So you don't rely on the existing taxonomy. You create your own categories depending on the codes that will emerge. For example, these are the open codes: waiting, increment, automate. These are the words: progress, increment per second, upgrades, find boss, multiple game levels, increment per click, one resource clicking. You connect that to a concept, like click to manage, and then you create category. So where is it categorized? Is it in derivative, micromanagement? It may be like single resource for this. Uh, so you categorize based on the concepts you get, kind of like getting the inductive information, let the concept or coding scheme emerge from the inductive session, and then categorizing it deductively. So it's kind of like that. So the analysis process that developed incremental games super category, each category above is part of incremental games. The process started with open coding of observations on idle games. Multiple codes are created. Concepts are discovered through analyzing the open codes and identifying common features. This is an iterative process where new codes are added, combined, or deleted. Each code is connected to one or more games and can be combined to form new concepts. Concepts are analyzed to find common relationships and thus categories emerge. In the diagram, coloration is only to aid in reading. The left grouping is to show that all contained codes are part of click to manage and click to progress. So these are the actual codes that we've discussed in the previously, the upgrade. So those are the words that we uh, found important with regards to our study. Using grounded theory helped to develop a better understanding of idle games. In contrast to other gaming taxonomies that feature interactivity and interaction strategies, the idle games taxonomy is based on game rules and their basic underlying structure. But what makes idle games interesting? Idle games value and reward waiting. So game rules force players into an idle state, during which resources accumulate and players can think about their future choices. So it's a different kind of game. So the games that was applied in previous or the games before were not applicable here because you're not trying to get the person to play a lot. You're trying to do the opposite. You're trying not to avoid them playing, such as in investing. You're trying to avoid touching or seeing that investment so that it could grow more in the future. System-based frameworks for large projects where the researcher is interested in how to best introduce a new technology and what is it is its impact afterward. It is necessary to analyze many sources of data collected over a long period of time. Conducting analysis of small fragments of conversation or identifying themes from interviews may be useful for highlighting specific working practices, but understanding how a whole social tech technical system, for example, a hospital, corporation, local council, or airport, works at scale requires a different kind of analytical framework. So for researchers that wants a large scale of data for a long period of time, conducting a small fragments that we used before, such as critical incident analysis, will not work because you're trying to look at a different subsets or sections of the system at the same time or in parallel. Socio-technical systems theory. Social-technical systems theory make explicit the fact that technology and people in a work system are independent. It's based on research in 2014. Rather than trying to optimize either the technical subsystem or the social subsystem independently of each other. So you're trying to do that in parallel, the people and the technology. STS suggests that this interdependency be recognized and the system be treated as a whole. So you need to recognize that these are interconnected. You cannot like really break them and treat that as a whole. The the ideas behind STS theory were first conceptualized around coal mining in the 1950s. See Trist and Barnford, 1951, for example. But it also has a long history of being applied in hospital and healthcare settings, as well as manufacturing and social media systems. So these are the big industry where this is useful. Healthcare, manufacturing, social media systems. Martin Maguire in 2014 highlighted the importance of socio-technical perspective with the rise of virtual organizations. Ken Eason in 2014 identified five significant and enduring aspects of STS theory. First, task interdependencies. If people are focused on one large task, then the division of subtasks between them inevitably sets up interdependencies that are critical to understand. Understanding these interdependencies is particularly useful for recognizing the implications of change. So, in a system, you're trying to divide the work or the subsystem to different people because of the principle that we only have limited resources. So, you're trying to divide that and then give that to people. And the recognition that that is interdependent is the first principle of this. Technical systems are open systems. STS are influenced by environmental factors, including physical disturbances and financial, market, regulatory, and technical developments. So it also recognizes that the environment of the people where they live, such as we can compare this in the attention, the salient information that affects the people unconsciously, which is their environment. So it recognizes that as well. Heterogeneity of system components. The overall task is undertaken by humans in the social. So one of the, I'll explain another concept about this second point. But hetero, let's explain now. So basically, this second point actually is what most people actually are being. They don't notice this that their environment, for example, the school, the company, or their groups actually define their most of their life outcomes. But most people believe that like the their choice define their outcomes. But yeah, this what this means about this thinking about systems is that you recognize how important your environment is. In fact, if you choose the right environment, it's easy to choose the right subset of data that you will that you will do, or it's easy to do your job or to excel in your career. Heterogeneity of system components, the overall task is undertaken by humans in the social subsystem using technical resources in the technical subsystem. Both need to be resilient. Technical components can evolve while humans can learn, develop, and change the technical components to address challenges of the future. So you are also measuring how resilient a system is. So since humans are involved, their environment and the technology, you're trying to make sure that those are resilient. Practical contributions. STS theory is making practical contributions in analysis of existing systems, summative evaluation of a major change through potentially predicting challenges before changes are made, and in designing socio-technical systems that are co-optimized. Fragmentation of design processes in a complex socio-technical system. There are different design processes, and this can result in fragmentation. Flexibility in specification, local focus in design, user-centered design, and system evolution will overcome this. So, because this is a complex since it was being used, for example, in social media, the rules in Philippines for developers are different for rules in other countries. They adopted this because they know that you need to adapt or evolve with the system. So they are using this technique, social technical systems theory. Distributed cognition of teamwork, investigating how information is propagated through different media is a key goal of this approach. And while distributed cognitive fit provides a good theoretical framework for analyzing systems, it can be difficult to apply in practice. The Decode framework was developed as a method to support the application of distributed cognition. It provides a framework of models that can be constructed from a set of collected data, for example, ethnographic, interview scripts, artifacts, photographs, and so on. So all the observation tools and the data gathering tools we discussed in the previous video can be applied on the distributed cognitive framework that we've discussed also in the previous video. So it's like an expansion of that. So it's more complex. Underlying each model is a set of principles detailed from the distribution cognitive theory. The models are as follows. An information flow model that shows how information flows through the system and is transformed. This module captures the information channels and hubs together with a sequence of activities and communication between different team roles. A physical model that captures how physical structure supports communication between the team roles and facilitates access to artifacts. So you're creating model or you want to create a model that support the communication between the team roles and access to artifacts. This model helps to describe the factors that influence the performance of the system at the physical level. An artifact model that captures how an artifact in this system support cognition. This model can be used to represent the key characteristics of an artifact and how it's designed. Structure and use can support team members. So you're trying to get the artifact as well that capture uh, the artifacts used in the system. So you're trying to also create a readable representation like this. For example, you know exactly that this is people. A social structure model that examines how cognition is socially distributed. So this talks about how cognition or energy are distributed in the whole system. Kind of like system that's designed in more details, right? But it's about like people, so like energy. This model maps the social structure to the goal structure, shows how work is shared, and can be used to consider the robustness of the system. A system evolution model that depicts how the system has evolved over time. This model provides some explanation for why the work is the way it is. Any design recommendation need to take this context into account. While the form of the model is not prescribed, the underlying principles support the model's development. For example, underlying the physical model are principles such as the following: horizon of observation, what an individual can see or hear; perceptual, how spatial representation aid computation; arrangement of equipment, how the physical arrangement of the environment affects access to information. So the this is the guidelines in creating this graph. So perception, observation, what an individual can see or hear, how the spatial representation aid computation. So you're trying to compute. Basically, you're trying to use the right kind of representation with the data that you collected. But basically, you're using the senses, what you can see in here, arrangement of equipment, how the physical arrangement of the environment affects access to information. So it's also about the consistency. The consistency that we've discussed in the previous video, which is the one of the basic principle of design. Because if there's a logic and sequence makes sense, it means that it's easy to make sense and then make it your own. So it's learnable, it's fast, etc. Decode has been used to understand collaborative work in remote and co-located software development teams, including the interactions between UX designers and software developers. It has also been found to be especially useful for studying how medical teams work and manage with ever-changing technologies that are introduced to their work environment. So here is the example. Ceremonies, demo meetings, informal demo. So you're trying to provide the meaning of the graph, flow type, bidirectional, unidirectional, bidirectional, more than one. User, blue is PO, developer, Scrum Master, UI designer, physical and virtual. So there you go. An information diagram can be good analysis of UX team interaction with software developers based on ethnographic data. So it was observed physically. Which analytical framework to use? Deciding which analytical framework to use for anyone's study can be daunting when reading about the diversity available. Table 9.6 is intended to help by listing the different approaches in terms of main types of data, focus, expected outcomes, and level of granularity. Conversation analysis for data recordings of spoken conversations, how conversations are conducted. So this is the most granular word level or finer, for instance, pauses and inflection. Insights into how conversations are managed and how they progress. The disadvantage of this, again, is that there's too much data. How conversations are conducted, etc. Recordings of spoken conversation. Again, it went back to how words or books provide level of this detail that is are very helpful. Discourse analysis, recordings of speech or writing from individuals or several participants. How words are used to convey meaning, implicit or hidden meanings in text. Word is still word, phrase, or sentence level. So here, you're not just looking for word, you're also looking for pauses and inflection. So if any one of you wondering how is discourse different to conversation analysis, the focus is how words are used to convey meaning. Here, how conversations are conducted. Content analysis, any form of text, including written pieces, video and audio recordings, or photographs. So, how often is something featured or spoken about? A wide range of levels from words to feelings or attitudes to artifacts or people. Frequency of items appearing in a text. So, it's mainly text and then the frequency. So you can also recognize the feelings, but it's not that granular as you thinking about the hidden meaning of their words. Interaction analysis, video recordings of naturality occurring activity, verbal and non-verbal interactions between people and artifacts. So you're trying to get verbal and then a non-verbal as well because of the video. So at the level of artifact, dialogue, and gesture, it's insights about how knowledge and action are used within an activity. So you're being more specific here because you're trying to get the activity and it's easy to like recognize. So it's like it's not that granular, grounded theory, empirical data of any kind. Um, System-based, so macro level organization. So you're trying to zoom out here, inside about organization, etc. Tools to support data analysis. Tools to support the organization of data include facilities for categorization, theme-based analysis, and quantitative analysis. These typically provide facilities to associate labels, categories, themes, and so on, with sections of data. Data search the data for keywords or phrases, investigate the relationship between different themes or categories, and help to develop coding scheme further. So, how do you do the category analysis and the critical incidents, and then quantitative as well? These typically provide facilities to associate labels like categories with sections of data, search the data for keywords. So you want to categorize the data in sections. You want to be able to search that. So one of the feature. You want to be able to investigate the relationship between different subset that you collected and help to develop the coding scheme further. Now you're trying to create a data that is applicable to you or on your framework that will applicable to your use case. Some tools can also generate graphical representations. In addition, some provide help with techniques such as content analysis and sometimes mechanisms to show the occurrence and co-occurrence of words or phrases. In addition, searching, coding, project management, writing and annotating, and report generation facilities are common. For example, NeVivo supports the annotation and coding of data, including PDF documents, photos, and videos and audio files. Using NVivo, fields notes can be searched for keywords or phrases to support coding or content analysis. Codes and data can be explored, merged, so explored, you're trying to dig more, merge, combine them, manipulate in several ways, either delete, update, uh, create, or read. The information can also be printed in a variety of forms, such as lists of every occasion a word or phrase is used in the data, and a tree structure, showing the relationship among codes. Like all of software packages, NVivo has advantages and disadvantages, but is particularly powerful for handling large sets of data and can generate output for statistical packages. Interpreting and presenting findings. Previous sections in this chapter have illustrated range of different ways to present findings as tables, numbers, and text through various graphical devices and diagrams as a set of themes or categories and so on. The reason for conducting a study at all is to communicate findings to others. So how the results are presented is just as important choosing right analytical approach. Different formats highlight different aspects of the findings. So as well as data gathering and analysis is undertaken, the format chosen also depends on the audience and the goals of the study. So let's say you find some discovery that you are the only one who found in your job. Basically, what you will do is you will, as much as possible, do it in graphical interface so that others can make sense of that faster. Because that's the hardest part, I would say, in data. It's the sales because you usually need to knock or check the pulse of people because it's not just about the data, it's also about the people that you are communicating with. So are they making sense? So what are their level of understanding? What are their profile, right? You're gonna base on that. But what works well is a graphical user interface. So the less cognitive load that you can provide to them, the better. So the smarter or the greater your analysis look like, even though it's not really new or something innovative. In some situations, the details of data collection and analysis will be included. For example, when trying to convince an audience about a controversial conclusion, this detail may include the snippets of data such as photographs of the context of use or videos of participants using the product. In other situations, only the salient trends, headlines, and overall implications are needed. So the style of presentation can be linear. Where possible, choose a set of complementary representation to clearly demonstrate the different aspect of the findings. So what you want when choosing the representational tool you use is you're trying to see consistency, a pattern that makes sense. So, for example, in writing, you want to have a sentence that connected to each other that form a paragraph. You want a words or the sentence that has in sequence that makes sense. So you want them to see that because it's powerful when people like see the connection, just like when words are formed to a sentence that provide a magical meaning. No. Consumer organization and technology companies regularly conduct investigations about technology use. Find such a report online and look to see how the results are presented. In particular, consider the following. What kinds of presentation are used? What is the left out of the report? What is the effect of presenting findings this way? Comment. We use a report from DS Scout published in 2016 investigating smartphone use. Available at dscout.com/people nerds/mobile touches and through a downloadable PDF report. Sorry. PDF report discount. Although the results are a little old, we choose this because it uses a combination of presentation styles, text, simple graphs, tables, and video. Note that the website and PDF report use different styles. First, graphs and pie charts are used to present demographics and app use. So here, along with list, tables, and typographic styles to emphasize certain findings. The report uses two other representations, a bubble diagram to show the relative use of different apps, and a timeline to represent a heavy user and an average user, and how their touches are spread across the day. So here's the graph throughout the day from 12 a.m. to 12 a.m. These two representations illustrate that developing new or modifying old representation to communicate findings you want to highlight is acceptable. There is very little text or description in the PDF report, and minimal details about the way in which the data was collected and analyzed. Further details are included on the web page but not in the report, suggesting that web page and the report are written for different audiences. So it's really depend on the profile again of your audience. For you guys, I show you this text, but maybe for others, if I want it to be more persuasive or like, for an audience that don't read a lot or maybe short memory lifespan because of social media, maybe you can provide them a different representation like this and just explain it and make it quick. They won't watch this long video. There's very little text or description in the PDF report and minimal details about the ways in which the data was collected and analyzed. Further details are included on the web page but not in the report, suggesting that web page and the report are written for different audiences. The way in which the findings are presented in the report has quite an impact. The bold and clear graphical image together with minimal but highlighted text mean that the messages are communicated in a straightforward fashion, including an edited video of participants' responses on the website, adds authenticity to the presentation. Structured notes. So here's different ways for us to provide a story. Three ways: using stories and summarizing findings. Structured notes. These notations follow a clear syntax and semantics, summarized from the application domain, such as with music applications, some from analysis approach, such as notation used in conversation analysis, and some have been developed to capture a holistic view, such as the work models promoted in contextual design. Bayer 2017. Tighter modeling conventions with more precise syntax are particularly appropriate when details need to be communicated. For example, notations to represent flow, decision-making, and dialogue structure are used when deciding chatbots. So, when designing chatbots, you're trying to get a dialogue structure and then to represent the flow for chatbots, for conversational interfaces. Um, so discuss the use of an acyclic graph notation, so behavior trees, and an algebraic model in the context of kitchen containing range of IoT devices. So algebraic model for kitchen with a lot of IoT. So different ways to represent or different graphs to represent different situations. They compare these notations in terms of how they capture users' cooking flow. Advantages of using structured notation are the meaning of different symbols is well defined, and so it provides clear guidance on what to look for in the data and what to highlight, that it enforces precision in expression. So another thing with structured notations like this one, uh, you know what is the emphasis of the graph, such as this red, because of like our mental model. So you're trying to define as well a clear syntax for each symbol of the graph. So that's the advantage of structured notations. Okay, so let me just continue. Basically, in music application, the sheet music is like a notes, like rest, time signatures, uh, of that sheet music symbol has meaning, so you can easily understand it. It's like a programming language or any language really. Uh, Allows you to get combined symbols or words and then complete a meaning. Conversation analysis notation. So in call centers or user research, analysts use symbols like dot for short pause, double dash for longer pause, caps for shouting. This helps analyze tone, timing, and flow of conversations. Work models in contextual design like Hallbat's BAT and Bayer. Real-world example in UX design when observing how cashier works. Designer use flow diagrams to show the steps. Scan, bug, take payment. This help improve systems by seeing where delays or error happens. Flow decision making, dialogue structure in chatbots. When creating customer service chatbots, you use flowcharts that show paths like user asks refund and then arrow to the right and then check receipt, give refund or decline. Each back arrow is part of the structured notation. So here's an example, guys. Behavior trees. So in game designs or smart home, behavior trees help a robot vacuum. Explore dirty, yes. Start cleaning. These are nodes in a tree with logic. Algebraic models in smart kitchens. Real world example. So here's an example in game design or smart homes. It's like a simple arrow, guys, that makes a lot of difference. Algebraic models in smart kitchens. So you model the steps like this for IoT. Turn on stop sets temperatures that user stories. Storytelling is an easy and intuitive approach for people to communicate ideas and experiences. So it's not surprising that stories, also called narratives, are used extensively in interaction design. They're used to communicate findings of investigative studies and as the basis for further development, such as product design or system enhancements. First, participants such as interviewees, questionnaire respondents, and observed participants may have told stories of their own during data gathering, These stories can be extracted, can be compared, and maybe used to communicate findings to others, for example, to illustrate points. So, in the subset of your data that you collected, maybe there's some story there that you could provide so that they can understand that specific point you're trying to achieve. Second, stories or narrative based on observation, such as ethnographic field studies, may be employed for further data gathering. For example, Valeria Wright used stories as the basis of co-design workshops in their studies to explore the design and use of technologies to support older people. So, the data that you observe could be used as a story as well. So, you can create your own interpretation of that story. Um, that will make you um, that will allow you to create more interpretation from that story. So you're trying to like uh, chopping the subset and then chopping it again. Including specific stories gives authenticity to the findings, and it can add to its credibility provided the conclusion are not overstated. Making a multimedia presentation of the story by adding video or audio, excerpts, and photographs will illustrate the story further. So this is another kind of like using the right representation because what you're doing is you're using photographs to better illustrate or activate the perceptual awareness of the audience. This kind of approach can also be effective if presenting data from evaluation study that involves observation, as it's hard to contest well-chosen video excerpts of people interacting with technology. So it also adds credibility because they see that in um, real case. Third, stories may be constructed from smaller snippets, repeated episodes that are found in data. In this case, stories provide a way of rationalizing and collating data to form a representative account of a product's use or a certain type of event. Masha Honari et al. 2018 described their design of video stories to capture the lived experiences of caregivers for people with severe mental illness. So they tried to capture the lived experience of caregivers. Their aim was to create a set of video-based stories that could be used in an online setting to provide support for caregivers. These stories were constructed around personas developed from interviews with caregivers and using the experiences described by the interviewees. So they interview first the caregiver and then they create a story from that. They were presented by our actors to maintain privacy and to address the complex ethical issues surrounding severe mental illness. In this way, the stories were authentic yet anonymous. Summarizing the findings, careful interpretations and presentation of the study results is important so that findings are not overemphasized and evidence is not misrepresented. Overgeneralizing result without good evidence is a common pitfall, especially with qualitative analysis. For example, think carefully before using words such as most, all, majority, and none. Be sure that the justification reflect the data. As discussed in Box 9.1, even statistical result can be interpreted in misleading way. So even the data that you collected from real life can be interpreted in different way if you put that out of context, you know. So it's easy to like be misled on this data. Information is good, but the right analysis of information is better. So that's what the summarizing the findings emphasize. So we can again summarize findings in different ways using different graphical representation. Consider each of the following findings and the associated summary statement about it. For each one, Comment on whether the finding supports the statement. First finding. Two out of four people who filled in the questionnaire checked the box that said they prefer not to use the ringback facility on their smartphone. Statement. Half of the users don't use the ringback facility. So that's the finding and that's the statement or conclusion. But then again, the questionnaire didn't ask if they use the ringback, just whether they prefer to use the ringback facility. In addition, two users out of four is a very small number of participants, and it would be better to state the actual numbers. So that's the example of summary and a conclusion got from it. But we're not gonna discuss that. I would recommend you to just pause this video and just read that. But these are the in-depth activity. The goal of this activity is to practice the data analysis and presentation. Assume that you are assigned to analyze and present the findings of your data gathering in-depth activity from Chapter 8 to a group of peers, for instance, via a seminar. Review the data that you gathered and identify any qualitative data and any quantitative data in the dataset. Is there any qualitative data that could sensibly and helpfully be transmitted into quantitative measures? If so, do the translation and add this data to your quantitative set. Consider your quantitative data. Decide how best to enter it into spreadsheet software, for example, how to handle answers to close-ended questions. Then enter the data and generate some graphical representations. As the dataset is likely to be small, think carefully about what, if any, graphical representations will provide meaningful summaries of the findings. Is there any data for which simple measures such as percentage or averages will be helpful? If so, calculate the three different types of average. Consider your qualitative data. Based on your refinement of the study question, improving product, identify some themes in the qualitative data. For example, what features of the product cause people difficulties? Did any of the participants suggest alternative designs or solutions? So, what features of the product people got difficulties? Did any participants suggest alternative designs or solutions? Refine your teams and collate excerpts of the data that support the team. So you're actually refining a team here. You're not relying on your initial team. So as you can see here, we enter it in a software before we refine the team. But sometimes you refine the team first before you put all in the software. So identify any critical incidents in the data. These may arise from interviews, questionnaires, responses, or observations. Describe these incidents carefully and choose one or two analyze in more depth, focusing on the context in which they occurred. Collate your findings and what you want is to be clear on these critical incidents and then analyze it deeply. Like, does it make sense? Ask for like other opinions, and then try to ask ChatGPT, etc. Collate your findings as a presentation and deliver them to a group of peers. Review the presentation and any questions from the audience. Consider how to improve the analysis and presentation. In a way, this is how you create a book, right? And another thing that I want to add here before we end is that this thing that we're doing, we're teaching, we're taking notes, we're trying to make vocabulary, or we're trying to organize these concepts into our brain, such as salient information, inductive, deductive, actually save a lot of cognitive load because you're organized, right? Based on the basic attention of attention, it must be have a clear goals. Second, we must have uh, we must organize, right? Salient information. The more organized that support our goals, that helps us make sense of things, right? Uh, so in Tagalog, wag nang pahirapan ng sarili natin. So summary, this chapter describes in detail the difference between qualitative and quantitative data and between qualitative and quantitative analysis. Quantitative and qualitative data can be analyzed for patterns and trends using simple techniques and graphical representations. Qualitative data may be analyzed inductively or deductively using a variety of approaches. Thematic analysis, an example of inductive analysis. So thematic analysis is actually uh, example of inductive analysis here because you don't have a clear goal yet. So how do you have clear goals? You use thematic analysis, inductive, and data categorization, an example of deductive analysis, are common approaches. So these are the commons. That's why we're talking about it a lot. Inductive uh, and deductive for data categorization. So it's a team, right? When I think about writing, when you're writing a paragraph, you always need to have a one point in each paragraph revolving there. So it's kind of like this. It's just that in paragraph, the category is the paragraph, or the sentence is the category. The point is the theme. You're trying to identify a theme. So there, so you're creating a patterns that will easy for you to remember, right? If you have this structure, consistency, pattern, one point, you have this one point or clear theme that allows you to basically organize, right? So that you can easily achieve your goal. Key points: the kind of data analysis that can be done depends on the data gathering techniques used. Okay. Qualitative and quantitative data may be collected from any of the main data gathering techniques: interviews, questionnaire, and observation. Quantitative data analysis for interaction design usually involves calculating percentages and averages. There are three different kinds of average: mean, mode, and median. Which is most appropriate depends on the characteristics of the subset. Graphical representations of quantitative data help in identifying patterns, outliers, and the overall view of data. So if you graph the quantitative data, kind of like doing a critical incident analysis because it allows you to find outliers. Not just outliers, but also the patterns. So you're also getting the theme. So these are the hidden advantage of graphical because I mean, texts are good for details, but there's also a beauty in graphical interfaces. Analysis of qualitative data analysis may be inductive, in which themes or categories are extracted from the data, or deductive, in which pre-existing concepts are used to interrogate the data. So a qualitative can be categorized or it can be thematized. In practice, analysis often proceeds in iterative cycles combining inductive identification of themes and deductive application of categories of new themes. So yeah, it's an iterative process. Which analysis techniques to use is closely coupled to the data that is collected and depends on the goals of the study. Again, it depends on the data and the or the profile and the main theme. Several analytical frameworks exist that can be used to guide and extend the basic qualitative techniques. They focus on different levels of granularity and emphasize different properties of the dataset. So the tools that we discuss here is only like this initial. Like you can like invent your tools. Maybe you will be able to discover something. So there, it depends on granularity. So that's how we organize it. Yeah, and thank you for watching, guys, and see you in the next video. We will discuss, I think, clear requirements. Yeah, emphasizing the importance of gathering requirements. Again, thank you for watching. See you on the next video. Peace.